Okay, so here the prefix is meth, and if it is a hydrocarbon, the name of this hydrocarbon is methane. But in case if it is used as a group in a basic chain, for example, like this is the basic chain and there is a methyl group, so then it is called methyl. And similarly, ethane or ethyl, propane, propyl, butane, butyl. So the general formula is CnH2n plus 2, and every molecule follow this formula. And why is this CnH2n plus 2? If you see here, then every carbon has two hydrogen atoms up and down, but additional two hydrogen on the one hydrogen on each terminal. So this is CnH2n plus 2. So this plus 2 is due to the ending hydrogens on the terminal. And otherwise, every carbon has two hydrogen atoms. So that's why this is the general formula for an alkane. And similarly, you can see have everywhere. So this is CnH2n for all the alkanes, 5 carbon pentane, 6 carbon hexane, heptane, octane. We have drawn all the stretch chain carbon atoms, stretch chain hydrocarbons. Similarly, nonane, decane, undecane, dudecan. Now, alkene, CnH2n. Why it is CnH2n? Although it also has some terminal hydrogen atoms, because two of the hydrogen atoms are removed due to the presence of double bond. Because when double bond develops between any two carbon atoms, then definitely they have one less hydrogen atom. Each of the carbon has one less hydrogen atom. So two carbon atoms are lesser than an alkane. So that was the plus two. It has been removed. So CnH2n. So this is alkene. Ethene. It starts from ethene because carbon-carbon double bond is necessary. So at least two carbon must be there. So ethene, propene, butanene, pantwanene, hexwanene, heptwanene, octwanene. And according to 2013 recommendation of I.U.P.A.C, the number must be before the name of the suffix. So that's why we are writing pantwanene. But previously, we also used the term 1-pentene, and it is still used in Pakistan and India in their local educational systems. But according to 2013 recommendation of I.U.P.A.C, this is wrong. Okay, and that's why Cambridge always follow this. Cambridge or Edexcel, Pearson board, they always follow this 2013 recommendation. And similarly, nonene, decene, undecane, dodecane. Undec 11 carbon, dodec 12 carbon. Although this is not the part of your A-level syllabus, and but it is the part of intermediate syllabus. Anyway, but remember that in all the cases, I have drawn only one of the nonene because nonene could be this double bond could be anywhere, not necessary that it should be on one position, but because I have drawn these homologous series, that's why I have drawn the double bond only on the first two carbon atoms. Now ethyne, because of the triple bond, two more hydrogen are removed. So that's why it has the formula CnH2n minus 2, because two more hydrogen atoms have been removed. So ethyne, because at least two carbon atoms are necessary for making triple bond in between them. So that's why it starts with ethyne, propyne, and then we should mention the number because butane could be but1-ine or it could be but2-ine. So that's why it is necessary to mention the position. But up to propyne, not necessary, because definitely from where the triple bond is there, it should be the number 1 carbon, then number 2 and number 3. But here the numbering could be changed. That's why either in alkene or alkyne, the numbering is required is from the 4 carbon chain. Similarly, pent-1-ine, hex-1-ine, hept-1-ine, oct-1-ine, and that's all. Now, the secondary suffix. The secondary suffix is used for the functional groups along with the hydrocarbon. And some of the organic compounds possess all the functional groups possess the suffix. For example, you have studied in your O level or um, in your early classes that there could be alcohol group, alcohol, all. So all the alcohols ending on all, propanol, butanol, and acids ended on butanoic acid, ethanoic acid. So there are different functional groups. So secondary suffix is written after the primary suffix. And you know the primary suffix is actually an, in, or ine. These are the primary suffix that we have studied in our previous class. And after removing this E, or sometime we do not remove, we will see the rule and we add the secondary suffix. And suppose if it is alcohol, then there would be an all, ethanol. So there would be some more example I will see. So secondary suffix is used to indicate the functional group in the organic compound, and the secondary suffix is written after the primary suffix. While doing so, the following rules should be followed. If the secondary suffix begins with a vowel, for example, ol, oic acid, or etc., then the terminal E has been removed. See, I have removed the E. Okay, so after dropping E, it becomes anol, anoic acid, anon. On is for ketone. Ketone ends on O-N-E. It is again vowel. So whenever there is a vowel, we drop the final ending E of the primary suffix. The last terminal E retained. Sometime we retain it because sometime if there are two OH groups, for example, if the compound is this, so the name of this compound is ethane, eth, because of the 2 carbon atoms, and N, because carbon-carbon single bond is there. But for all, you can write, if it is 1, then it is 2, ethane, 1,2-diol. So instead of all, there would be diol. So this is not the suffix. That's why we retain E here and we write 1,2-diol. Because this D is not vowel, D is the consonant. So see, if the secondary suffix begins with a consonant and the secondary suffix is added after E. Okay. Another example, see, if this is CH3, CH2, CN. This is the carbon number 1, 2, 3. So what is this? This is propanenitrile. So we write propan, and without removing or without dropping E, we write nitrile. Although nitrile is not the part of your syllabus in A level, nitrile is not, sorry, nitrile is the part of syllabus. Sorry, I forgot. Okay. So propanenitrile. So here it is the consonant. So we retain this E. Numeral prefixes like this: diol, triol, tetraol, or it could be for any other functional group. Right now I have shown this. Now see the secondary suffix for various functional groups. See, these are the secondary suffixes, this column. So these are the secondary suffixes, and these are in priority order. Alkanoic acid, the general name is carboxylic acid for this group of organic compound. The general formula is RCOOH, and sometime we can write RCO2H. R is the alkyl group. It the functional group is COOH. It could be written like this. And its prefix that is not the part of our syllabus. It is carboxy. And its suffix is oic acid, and we will use this. And ester has two alkyl groups. The alkyl group, they first see that it could be shown like this. So the R group that is bonded to the single bonded oxygen here, that is not the part of the chain. Chain start always C double bond O. So this R is written separately. Then we complete the name, and the suffix is OAT. When you will see the nomenclature of ester, then you will understand then what I'm saying. Acid halides can also be written like this. X could be Cl or Br, but usually it is not I. So these are called halocarbonyl, and the suffix oil halide, it could be chloride, bromide, iodide. Not iodide generally, chloride or bromide. And this group is called amide. In open form, it is like this. So this is suffix is used amido, and amide is the suffix, and this is the prefix. These are the prefixes. Nitrile, I have told you. And actually this is carbon, nitrogen, triple bond. Aldehyde, al, and both of them have oxo suffix. Remember that these prefixes are also used. These are the prefixes. Sino for nitrile, oxo for alkanals, which are aldehydes, and for alkanones or ketones, it is also oxo. But the suffix is different, al and on. We frequently use these suffix. Hydroxyl hydroxy group is there in alcohol. So all is the suffix we have already discussed. SH for and better not to use hydroxyl. We use hydroxy only. And SH is the mercaptan. So mercapto is the prefix, while suffix is thiol. NH2 is amino. Its suffix is amine, while prefix is amino. We also use this. Imine actually in two terms, and better to leave it. Okay. Imine, the term is used for those which have two alkyl groups, and sometimes it is used when carbon nitrogen double bond is there. but this is not the part of our syllabus, so leave it. Now see, these are some example. This is the carboxylic acid, and it has 4 carbon atoms, 1, 2, 3, 4. So but, N is the primary suffix, oic acid is the secondary suffix, but we write the name butanoic acid. We have dropped the E of the primary suffix, removed. Okay, but in case of nitrile, we retain this. Okay, and ethanediol, I have already given you this example. We retain this, not removed. It is retained. And similarly, butane dioic acid, this is the basic chain. So basic chain contain 4 carbon atoms. But remember that here we have not written the number because carboxylic acid can be on only the terminal position. So if it is butane dioic acid, heptane dioic acid, hexane dioic acid, whatever the dioic acid is there, then definitely it would be at the terminal. Okay, it cannot be in between because this is the functional group. So only one valency is free to connect the hydrocarbon chain. So alkyl group can be only one at one position. So if there is dioic acid, so definitely other oic acid would be on the other terminal. And similarly, if you see the aldehyde is also on the terminal position. So in several cases, we do not write the number of the aldehyde because like carboxylic acid, it is also at the end. Okay. So we will see individually for every compound for its nomenclature. Now see the carboxylic acid, and these are the displayed or the structures of the functional groups. Okay, the same thing that we have seen there. So this is the carboxylic acid, and here you can see that methanoic acid. This is ethanoic acid. This is propanoic acid, and this is butanoic acid. And this is another way of writing the formula. Pantenoic acid, propanedic acid. Now see, here we have written the E. In every other condition, we have removed because the next suffix itself contain a vowel. So avoiding two consecutive vowels, we have I.U.P.A.C suggested the rule to remove the E from such compounds. And this is also butanedic acid that we have seen previously. Okay, now see, the functional group is ester. Ester has different designation. It can be designated by this, this, or this. And the suffix OH is used. Now see, the carbon atom which has double bonded oxygen or the carbonyl carbon, it is also called the carbonyl carbon. It is the part of the chain and it is always one. And this is two. And it is not on any chain, it is separate. So it is written separately and we keep the gap between the name. See, here we have kept the gap. Otherwise, in I.U.P.A.C name, there is no gap. Okay, see previous slide. See, in this continuous name, there is no gap. Oic acid, so gap is already there. That gap is although it is there, but in the name there is no gap. This gap was already in the name of the suffix. Okay, so the name is the methyl ethanoate. Similarly, this whole group is ethyl. Whole is considered as a group, ethyl ethanoate. And here, although there are two carbon atoms and there is only one carbon atom, but this is the basic chain. This is not the basic chain because this is the functional group and it is attached to this side. So that's why the functional group carbon must be included in the basic chain. So if it is must to be included there, then we ignore the phrase that parent chain must be the longest. Parent chain may not be longest. Okay. So this is the parent chain contain here only one carbon atom. So one carbon is methanoate, methanoate. And this is written as the separate, just like this, ethyl methanoate, because this is the basic chain. Now see, if it is written like this is not carbon dioxide, this is this bond, but it is written like this. So this is the group and bonding is shown here. So this is the basic chain. So methyl butanoate. And here, this is the basic chain. So basic chain, you can either name from here 1, 2, 3, and 4, or you can write the name from starting from here. Both are same. But there are methyl group on both the position. So we will write dimethyl butane diuate. Why diuate? Because ester group is on both the end. But remember that such type of naming is usually not the part of A-level syllabus, but it could be in intermediate or any other Indian board. And similarly here, one side is methyl, other side is ethyl. So methyl and ethyl are there, and the basic chain comprises 3 carbon atoms. So what should be its name? This is ethyl, methyl, there is a gap, there is also a gap, propane diuate. So we can write on one oxygen methyl group, on another oxygen ethyl group. Now the student asked the question, sir, what if we write on other side? No problem, because molecules have no right or left. You can turn it, if you turn the molecule on 180-degree, then the molecule would be the same. Just changing the on rotation, molecule cannot be changed. Okay, but it is written in alphabetical order: ethyl, methyl, propane diuate. We never write it methyl ethyl propane diuate. That would be wrong. But remember that such type of nomenclature is not the part of our A-level syllabus. A-level only these simple types of nomenclature. Now the functional group is acyl halide, that are also called alkanoyl halide, alkanoyl halides. So if it is Cl, then this is ethanoyl chloride. Again, the vowel is there, so E has been removed. 1, 2, 3, propanoyl chloride, butanoyl chloride, 1, 2, 3, propanoyl bromide, 1, 2, 3, 4, 5, pentanoyl bromide. And here on both the position, these alkyl group is present. So we retain the E. Butane dioyl chloride. Again, this is always on the terminal. So we do not need to mention the position. Got it? Yes, tell me.
Got it.
Okay. Now see, amides. Amides can be written like this or like this. So again, ethanamide because A, so E has been removed. Propanamide, butanamide. Again, this is the structure formula of propanamide. This was the displayed formula, not fully displayed because functional groups are not displayed. We have not written the bonds between nitrogen and hydrogen. So this is not the fully displayed formula, but partially displayed formula. And this is the structure formula, propanamide. Both are the same things. And 1, 2, 3, 4, 5, pentanamide. And this is the diamide. So butane diamide. Again, amide also has only one free valency that could be bonded to the alkyl. So it is always on the terminal. So this is butane diamide. Now the nitriles, as I have already mentioned that in nitrile carbon nitrogen triple bond is there. So this is methanamide. And remember that this is also hydrogen cyanide. This is the common name. Hydrogen cyanide is the common name. And this is the I.U.P.A.C name. And this hydrogen cyanide is also accepted by I.U.P.A.C. This is ethanamide, 2 carbon atoms. Sorry, amide kya kiya main? I'm sorry. Ethane nitrile. 1, 2, 3, 4. Butane nitrile. Propane nitrile. Pentane nitrile. And this is 1, 2, 3, 4. Butane dinitrile. Here we have written the E. Everywhere we have written the E because the name of the suffix is consonant. Okay. Now see, aldehyde suffix is al, methanol, ethanol, 1, 2, 3, 4, butanol. And again, we have not mentioning the name, mentioning the number. Lucants are not mentioned because if aldehyde is there, it must be on the terminal. And it can also be represented by CHO. So this is CHO. So 1 carbon is this, 2, 3, propanol, 1, 2, 3, 4, 5. Pentanediol again, because it is always on the terminal position, so not necessary to mention this. Again, 1, 2, 3, 4. Butanediol. Ketone, it can be anywhere. So numbering is must. And the suffix for ketone is on. So this is propanon. But here the numbering is not necessary because in propanon, it is understood that the carbonyl carbon must, this is called the carbonyl carbon. So carbonyl carbon must be in the mid of the chain because for ketone, it is necessary to have on both the end carbon atoms. So if it has total 3 carbon atoms, so definitely it would be in the middle. So we don't bother to write propane 3 on. Although you can write it, propane 3 on is not wrong, but it is not necessary to mention the locant means the number here. But it is also because if there is only one ketone, then definitely it would be on second position. If it would be here, then we number the chain from here. For example, if the situation is like this, see. Then we start the numbering from here, 1, 2, 3, 4. And here we start the numbering from here, 1, 2, 3, 4. So the name of the compound is butane 2-on. So it is always butane 2-on. So it is enough to write the butanone. Although you can write butane 2-on, but it is more correct. Okay. But for in Pakistan, for intermediate student, we suggest them that they should write propane 2-on. Okay. But according to I.U.P.A.C, it is not necessary to mention the position of the ketone group in propane and propanone and butanone. But it is necessary to mention the position in pentanone, because pentanone could be pentane 3-on, the double bond with oxygen, that is the carbonyl carbon. It could be there as well. And if there are two double bond, then better to use butane 2,3-dione. But even if it is named as butane dione, then it is also correct. Why? Because it is understood that in butane dione, if two ketone groups are there, then they cannot be at the terminal. They must be in between. So that's why there is no other possibility. So if you write butane dione, then it is also correct. Okay. Now, but here the numbering is necessary. Now here you cannot write pentane dione. If you write pentane dione here, then it is wrong, because pentane dione could be 1, 2, 3. Here it is 2 and 3 position, but it could be here. Then that would be 2,4-dione, and pentane 2,4-dione. So that's why here numbering is necessary. If you will write the name without numbering, it is considered wrong. Similarly here, it is important to write the number, because it could be anywhere else. So the position is hexane 2,5-dione. Start from the nearest position, just like the double bond. Hexane 2,5-dione. Here numbering is required. So again, I will say that if you write hexane dione, then it is wrong. Now, after this, we are going towards alcohol. Alcohol, we have already mentioned that OH is there, and its position, mentioning the position after after ethanol is necessary. Up to ethanol, it is not necessary. But even for ethanediol, numbering is necessary, because it could be 1,1-diol. It is possible that 2OH can be on the same carbon atom. So the name of this compound would be ethane 1,1-diol. Now, similarly, this is propanediol. So propanediol could be propan 1-ol. Sorry, not diol. This is propanol. Propanol could be on first position or second position. So if it is on second position, this is called propan 2-ol. If it is on first position, then it is propan 1-ol. Now see, it is on first and the second position. This is in the condensed form. So 1, 2, 3. This is propan 1,2-diol. Here, writing the number is important. If you will not write the number, then you cannot understand the original compound. because it could be 1,2-diol and it could be 1,3-diol as well. Now CH2 means you will write CH2 twice and OH is here, and here OH is in bracket. It means it is on this CH, and here it is CH3. So numbering start from where the OH is nearest. So definitely it is 1, it is 2, it is 3, it is 4. If you start from here, then the 1, 2, 3, 4. So 2 and 4 position would be for alcohol, but from here 1 and 3 position. So 1 and 3 is near. So the name of the compound is butane 1,3-diol. And again, you can notice that here E is written, E is retained, but E is dropped, E is dropped, E is dropped. Okay, and reason, these are the metric prefix which contain the consonant. And now this is 1, 2, 3. So this is again 1, 3, but pentane 1,3-diol. Okay, and after alcohol, these are amines. Amines have the same way of writing the functional groups. Okay, methanamine, ethanamine. Now ethane 1,2-diamine numbering is necessary. Similarly, propane 2-amine, propane 1,2-amine, butane 1,3-diamine, and pentane 1,3-diamine. Okay, up to there, the almost the mechanism is the same. Okay, so now the next lecture would be about the further prefixes. Okay, so now